ASTC and the Pythagorean Trig identity. All right, so ASTC. What is ASTC? Well, here's what it stands for. When you have a coordinate plane, so you have x and y, here's your x-axis, here's your y-axis. All right, this is quadrant number 1, of course, and this is quadrant 2, this is quadrant 3. Oops, I'm supposed to have 3. And this over here is quadrant 4. Now, in quadrant 1 is the A. What the A means is all, meaning all 3, well, 6 actually, all the trig functions are positive. Okay, sine's positive as well as cosecant, cosine's positive as well as secant, tangent's positive as well as cotangent. All right. Now the S is right here. All right, and what that means is only sine is positive. So you have your functions sine, cosine, and tangent. All right, your sine is positive in this quadrant, but your cosine and your tangent are both negative. All right, your t goes here. You probably know the pattern by now, and your c goes here. So your sine, your cosine, and your tangent, sine, cosine, tangent. So in quadrant 3, the tangent is negative. Quadrant 4, positive, I'm sorry. Quadrant 3, the tangent is positive. Quadrant 4, the cosine is positive. Then, of course, sine and cosine are negative in quadrant 3. Sine and tangent, as well as their reciprocals, are negative in quadrant 4. All right. Easy way to remember this that I was taught is all students take calculus. All right, all students take calculus. 2 years ago, my students remembered amazing super turbochargers and it worked for them. Anything you want to use, just remember that in quadrant 1, all the trig functions are positive. In quadrant 2, only sine and cosecant are positive. In quadrant 3, only tangent and cotangent are positive. And in quadrant 4, only cosine and secant are positive. Now you might be asking me, how does this help us out to know this? Well, I'm glad you asked. Say I gave you an example. Okay, here's an example. It says, in which quadrant I'll abbreviate that as quad, is alpha if the sine of alpha is less than 0 and the cosine of alpha is less than 0. Okay? So, what you would look at is you'd want to look at this. You'd want to find all the places where the sine is negative, because since it's less than 0, that means that the sine is negative. So, where are all the quadrants where a sine is negative? Well, that's quadrant 3. That's supposed to be a 3. I don't know why I have such a problem with that. In quadrant 4, in both 3 and 4, the sine is negative. Now we have to narrow these two down to where the cosine is negative. All right, where the cosine is negative in 3, but it's positive in 4. So that means our angle cannot be in quadrant 4, because if it was, our cosine would not be negative. So that means that our angle has to be in quadrant 3, because that is the only quadrant where both the sine and the cosine are negative. It's the only one where sine and cosine are negative. All right. I'll give you a U try. I want you to try this one. In which quadrant is alpha if the tangent is negative, if alpha is less than 0, and the sine of alpha is greater than 0? Alright, so take a few moments and figure this one out. Alright, so the tangent is less than 0, so that means the tangent's negative and the sine is greater than 0. That means the sine is positive. So let's start out with this first one. The tangent is negative. Which two quadrants is the tangent negative? Well, it's negative in quadrant 2 and quadrant 4. Okay. Now, where is the sine of alpha positive? Well, if you go to quadrant 2, sine is positive. If you go to quadrant 4, sine is negative. So that means that our angle has to be in the second quadrant. Okay, that's the only way that this is going to work out, is if our angle is in the second quadrant. Okay, moving on. The Pythagorean trig identity. This is sometimes called the golden rule of trig. Okay, the golden rule of trig. And it says that the sine, why did this quit working? And it says that the sine squared of alpha plus the cosine squared of alpha equals 1. All right, what this is not, now on here, you're not squaring your angle, okay? You may have not have seen this before, but here you're not squaring the angle. What you're squaring is you take the sine or the cosine of the angle, and then that answer is what you're going to square, okay? So you can really look at it as the cosine or the sine, whichever one, of alpha squared. Okay, to clean it up a little bit, what they do is they take the 2 and they drop it down on the cosine. They take the exponent and drop it down on the cosine. So they call it the cosine squared of alpha. Okay, so don't get it confused. Make sure you realize that when you see sine squared alpha plus cosine squared alpha, you're going to take the sine of your angle and square it and add it to the cosine of your angle squared. Okay? So, and if you're wondering how we know this, well, let me give you a visual. Here we have a circle, or at least as close to a circle as I'm going to get it. All right, go from the center. Okay, here's a radius. Let's drop a straight line down and draw this over. So what do we have here? All right, what do we have here? Well, we have a right triangle. How do I know we have a right triangle? Besides the fact that I drew it. Okay, so we have a right triangle. What does this tell us? Okay, well, if this is your alpha, okay, we know, and this is the unit circle, okay, this is the unit circle. We know that the unit circle is a radius of 1. So we know that's 1, without a doubt. All right, we know that this horizontal distance here is x. We know that the vertical distance is y, okay? And this is also why they call it the Pythagorean trig identity. Imagine that. The naming that actually makes sense. Because to find the length of the hypotenuse, you're going to use a squared plus b squared equals c squared. Or, in this case, x squared plus y squared equals 1. Or, since we know that the cosine of of alpha, is your x value, we know that this is the cosine squared of alpha plus, and we know the y value is the sine squared alpha equals, and you just bring the 1 down. So that's how they get your Pythagorean trig identity. Okay, that's how they get your Pythagorean trig identity. It all goes back to a triangle and the Pythagorean theorem. Now, if you notice, I've written it two different ways. Sine squared alpha plus cosine squared alpha equals 1, but down here I said cosine squared alpha plus sine squared alpha equals 1. Well, if you remember back to the addition property of equality, it doesn't matter which order you add. All right, it doesn't matter in which order you add. So both of these, this one here is equivalent to the one up top, up here. Okay, completely equivalent. Nothing wrong with either one. All right, you'll mostly see it this way because they usually write sine before cosine. But just know that they're the same. Okay, all right, let's look at an example. I like examples. Say the sine of 30 degrees, okay, equals 1/2. Right, and we know that the cosine of 30 degrees, oops, I put the degrees in the wrong place. We know that the cosine of 30 degrees equals the square root of 3 over 2. Alright, so let's plug these into the Pythagorean theorem and prove that they come out to 1. So we're going to have 1/2 squared, because this is the sine of alpha, squared, plus the cosine of alpha squared. Well, that equals 1/2 squared is 1 over 4, plus square root of 3 over 2 squared is 3 over 4, which equals 4 over 4, which, hey, look at that. It equals 1. And again, you may ask me the question, why do we have to know this? How is this going to be useful? Well, let's look at another example. If alpha is in the second quadrant and the sine of alpha equals 1/3, find the cosine of alpha. All right, find the cosine of alpha. So now what we have to do is we have to plug in. Well, we know the sine of alpha is 1/3, so it's going to be 1/3 squared plus cosine squared alpha equals 1. All right, let's go ahead and square this out. So this is going to be 1/9 plus cosine squared alpha, that's the squared, equals 1. Subtract the 1/9 from both sides. So the cosine squared of alpha will equal 8/9. Now, since this is squared, take the square root. So the cosine of alpha equals plus or minus the square root of 8 over 9. That's an 8. 8 over 9. Now, how do we know is it the positive one or is it the negative one? How do we know? Well, that's what ASTC comes into play. All right, we know alpha is in the second quadrant. So if you set it up real quick, you have AS. Well, only sine is positive in the second quadrant. So that means our cosine is going to have to be a negative number. So that means that to be in the second quadrant, our cosine of alpha is going to have to be negative square root of 8 over 9, because cosine is negative in the second quadrant. Okay? Cosine is negative in the second quadrant. All right? So I'm going to give you one to do now. I'm going to give you your U try. Let's go to a new page. All right. If alpha is in the fourth quadrant and the cosine of alpha equals 1/4. Find the sine of alpha. Go. All right, so let's get this going. So the cosine of alpha is 1/4. So 1/4 squared plus sine squared alpha equals 1. So 1/4 squared is 1/16 plus sine squared alpha equals 1. Subtract the 1/16 from both sides. So now sine squared alpha equals 15/16. All right. Now take the square root. So the sine of alpha equals positive or negative square root of 15/16. Okay. Now, is it positive or is it negative? Well, it says our angle's in the fourth quadrant, and we know sine is negative in the fourth quadrant. So therefore, our answer is the sine of alpha equals negative 15 square root of 15/16. Okay. So that has been your video on ASTC. All students take calculus, amazing super turbochargers. However you want to remember the ASTC is fine. Just remember what they stand for. A means quadrant 1, they're all positive. S means quadrant 2, only sine is positive. T is quadrant 3, only tangent is positive. C is quadrant 4, only cosine is positive. Then you have your Pythagorean trig identity, which says sine squared of alpha plus cosine squared of alpha equals 1. Okay? So make sure you understand the concepts in this video, and we will be working on problems going over this in class tomorrow. See you tomorrow.